right, welcome back. Sorry the video cut out, but here is that problem all worked out. Hopefully you can follow along. And let's move on to dealing with conjugates. If you have a problem that has a more complex denominator with a radical in the, or maybe two radicals added together, you're going to need to write your number one using something called the conjugate. Look at the relationship between the denominator here and the denominator here. Only difference is the sign in the middle. 3 plus root 5 times 3 minus root 5. These are called conjugates. Okay? You follow the same pattern. Numerator times numerator equals numerator. Denominator times denominator equals denominator. Notice that all the radicals will cancel out, and you'll just be left with integers. Let's try one. Let me show you the steps so you can follow along. All right, I'm going to give myself a little space here. Do not skip steps. It is complicated enough. Please keep the steps there. We're going to multiply by the conjugate. What's the conjugate? It's going to be 5 plus root 2. And we have to multiply by 1, so we're not changing the value. So we have it in the numerator and the denominator. Okay? Now, look here. In the numerator, it's kind of like doing this. 3 times 5 plus root 2. Okay? We could make ourselves a box like this. 3, 5 plus root 2. You end up with 15, 3 root 2. Okay? 15 plus 3 root 2. Now let's do the denominator. I think for the denominator, we'll go use our area model here. I'm going to put in 5 minus root 2 here. And on the top, I'm going to do 5 plus root 2. 5 times 5 is 25. 5 root 2 minus 5 root 2. And, okay, now here's the tricky one. We've had a minus sign. What's root 2 times root 2? That's the square root of 2 squared, right? Let's write them out. Space-wise, I'm going to need a little help here. I'm going to go ahead and simplify. This is the only one that needs to be simplified, so I'm going to do it here. Square root of 2 squared comes out. I end up with just negative 2. Okay. The 25 comes down. What happens with these two? If you have 5 root 2, and then you take away 5 root 2, what do you have? You have a 0 pair. You have 0 root 2's, which is the same thing as 0. So 25 minus 2 is just 23. All right, we're done. That's it. Can you simplify? No. Let's try another one. We've got 5 over root 7 plus root 3. Multiply by the conjugate. 5 over root, sorry, that's not right. All right, trying again. Over root 7 minus root 3 over root 7 minus root 3. Okay, numerator times numerator. I'm going to move this one out of the way for a while. Numerator times numerator. Let's see what we can do about that. First we make a box. 7 times negative root 3. This becomes 5 root 7. This becomes negative 5 root 3. Okay? 5 root 7 minus 5 root 3. Are there any like terms? No. Now we have to do the denominator. So let's start with root 7 plus root 3 times root 7 minus root 3. Root 7 times root 7 is just square root of 7 squared. Take the perfect square out, you end up with 7. Let's do this one. Back to the black pen. We end up with negative square root of 3 times 7. Can we simplify that? No. That just becomes negative root 21. Here we end up with square root of 3 times 7. All right, so we end up with root 21 here. And then here we've got negative root 3 times root 3, so that's negative 3 squared. Take the square root out, you end up with negative 3. Take all these blue numbers down. We've got 7 minus root 21 plus root 21 minus 3. Do you see a pattern? I got a zero pair in the middle. 7 minus 3 is 4. All right, and on the bottom here then, we just have 4. Can you reduce this in any way? No. All right, let me try another one here. 8 over 3 plus root 3. Multiply by the conjugate. Here we go. 3 minus root 3. Oh, sorry, 3. Oh, let's try that again. 3 minus root 3 over 3 minus root 3 equals. This time, watch what I'm going to do. I'm going to leave this as 8 times 3 minus root 3, just for a while, okay? And I'm going to concentrate on the denominator first. So let me pull this down to the denominator, where it belongs. Let's do 3 minus root 3, 3 plus root 3. Which two boxes are going to be important to us? And which two do you think are going to cancel out? See if you guessed right. 3 times 3 is 9. This becomes minus 3 root 3. This becomes positive 3 root 3. This becomes negative the square root of 3 squared. Pull out the square root of that perfect square, you end up with negative 3. Okay? Let me do that part in blue, actually. Negative 3. Okay, where are our zero pair? Right here. Right? So really, what was important to me was 3 times 3 minus square root of 3 times square root of 3. So I have 9 minus 3 equals 6. Denominator is 6. Look what I can do here. I can reduce 8 and 6. This becomes 3. This becomes 4. Now is the right time to start distributing this. Make myself a nice box. If you can do it without a box, that's okay. 4 times 3 minus root 3. End up with 12 minus 4 root 3. So my numerator is 12 minus 4 root 3. And on the bottom, I have a 3. Let's try another one. See if I have enough time to finish this one. Let's try 2 root 6 over 5 root 3 minus root 11. Multiply. We're going to use the conjugate. So 5 root 3 plus root 11. And on the numerator, the same thing. Okay. Start with the denominator. Let's pull an area model down here. We've got 5 root 3 minus root 11 times 5 root 3 plus root 11. Which two boxes are going to be important, do you think? Okay, we end up with 5 times 5 is 25 times square root. You know what? I want to reduce here. I want to simplify. So I'm going to do it like this. 25 times the square root of 3 squared. This one becomes minus 5 times 3 times 11, square root of 3 times 11. Here we have 5 times the square root of 3 times 11. And here we have minus the square root of 11 squared. I bet you can figure out what some of these are going to become. Perfect square comes out. I'm going to write it down here because I don't have enough room. 25 times 3. Look, these two are exactly the same. I end up with 5 root 33 minus 5 root 33. Is that a perfect a zero pair? Let me cross it out right away. I can see it. Cross that one out. Zero pair. This box, we've got a perfect square. So this becomes minus 11. Let me come up here now. 25 times 3 is 75 minus 11. What is 75 minus 11? 64. Okay, so the denominator is 64. On the top here, this is a little complex. Look at this first. Before we multiply, we've got 2 root 6 times 5 root 3 plus root 11. Okay. First step, we really need to reduce this. We can reduce this 2 and this 64. This just becomes an invisible 1. This becomes 32. Now multiply this out. Root 6, here's my box. I'm going to use a box this time since it's a little more complex. 5 root 3, root 11. Oh gosh. 5 root 3, root 11 on the top. Erase. There we go. Okay. Don't forget there's an invisible 1 here, so we multiply 5 times 1 and get 5. Here we have the square root of 6 times 3. Here we have the square root of 6 times 11. Okay. Coming down, we have 5 times 2 times 3 times 3. I see a perfect square there. Plus the square root of 2 times 3 times 11. Any perfect squares? No.